Alrighty guys, we're going to be finishing up one of our last couple notes for piecewise functions, okay? Where we're going to now be looking at given x values and seeing what kind of output they give us, okay? So looking up here, this is our piecewise function, okay? This little bit right here, okay? Now what we're going to go ahead and do is we're going to look at these individual x values, okay? So for instance, -3, 9, and 1, and we're going to see which equation they're supposed to go to. Looking at this first one, -3, okay, we'll notice that is going to be between -infinity and 1, because if you look at a number line, okay, think about that for a second. If we have 1 right here, well, it looks like -3 would be to the left of it, right? Be somewhere over here, okay? And so this is going to be between our -infinity and 1. Well, which equation does that talk about? Well, that talks about the 2x. So that means I'm going to plug my -3 into my 2x equation. Now, what is 2 times -3? Well, that's going to give me -6, and that is going to be my answer, okay? Now, for the next one we take a look at is 9. Well, looking at 9, that is to the right of 1, okay, somewhere over here. And that's going to be for my 3x squared, right? Because that's going to be between 1 and positive infinity, right? Positive being infinity way out there. So I'm going to go my f of 9 is equal to 3 times 9 squared. Okay, now that's going to be a pretty massive number there. That's going to give us 81 times 3. That's going to be 243. Okay, and that'll be my answer there. And then last but not least, we have a 1. Now, looking at this one, we notice for the first equation, we notice that 1 is not included for him. So this number 3 is not going to be for our first equation, but it's going to be for our second one, because you'll notice the second one has a bracket, meaning that that equation does include 1, and so we can go ahead and plug it in there. So we have 3. Actually, let me backtrack a little bit. Let me do my f of f of 1, and I've got my 3, 1 squared. So that's going to give me 1 squared. That's going to be 1. 3 times 1 is 3. And that right there is going to be the first set of my x values, okay, where I find my outputs, okay? So let's go ahead and take a look at 4, 5, and 6 now. Alrighty, so now we have f of -2. So if we think about that, where is -2 between? Well, we got to now look at these inequalities, and it might actually be beneficial to think of these inequalities as interval notation again, okay? So this first one, okay, is x is less than -6. So that means we have a -infinity to -6, okay? And it's going to be parentheses, okay, because we are not including it. For this next one right here, okay, we have from -6 to 0, but we are including it, so we have brackets. And then, of course, this last one, x is greater than 0, and so I've got a 0 to positive infinity, okay? So now let's use these inequalities and these interval notations to kind of try to find our answers. Now, looking at this right here, -2, I would venture to say that's between -6 and 0. Okay, so which equation does that talk about? That talks about our middle one. So that means I have my -2 minus 2. Well, -2 minus 2 is going to be -4, but we got to remember an absolute value, any number that's inside that absolute value, that's going to turn that number positive. And so our answer for this one is going to be 4. Now let's take a look at number 5. Now number 5, it says -10. Now where's -10 between? It's between the first one, right? -infinity to -6. So we're going to use that top equation. Okay, so I have a -10. Okay, so a negative times a negative, that's going to give me a positive, so I have +10. And then last but not least, we have this number 6 where it says 0, okay? Now looking at this one, we'd be tempted to use the bottom one, okay, the 100 over x, but we shouldn't. Reason why is because it's not included for him, right? The only place it's included is that middle one, right? Where it has those absolute values. So we're going to use that one instead. So I've got 0, absolute value of 0, minus 2, okay? And that's going to give me absolute value of negative 2, which is just going to be 2. And that right there is going to be my answer. Now, don't be discouraged by us not using 100 over x, okay? We just weren't needing him for these particular answers, okay? So 100 over x may have been used if, say, we use something maybe like a 10, maybe if we'd use something like a 20, okay? Because those would have been numbers that were greater than 0 going towards infinity, right? Well, let's go ahead and take a look at these bottom ones, okay? 7, 8, 9, and 10. Now, once again, you have the ability to go ahead and write these inequalities into interval notation. This one says x is less than negative 2, so we'd have from negative infinity to negative 2. And then we have x is greater than or equal to negative 2. So then this one is from negative 2 to positive infinity. Now let's go ahead and take a look at number 7. So number 7, you'll notice we're not given an x value. Now we're given a y value. So what we have to go ahead and do is we have to see where this y value, okay, fits into one of these two functions, okay, our x minus 6 or 2x minus 3, okay? So we have to go ahead and work backwards and try to see which one's going to work, okay? So we have our x minus 6 equals 10, and then I guess I'll put a little divider there, and then I've got 2x minus 3 is equal to 10, all right? Now solving for both of these, I'm going to add 6, okay, to the other side. 6 plus 10 is going to give me 16. Over here, I'm going to add 3 to the other side, and I've got 2x is equal to 13. And then I'm going to go ahead and divide by 2 on both sides. And if I'm not mistaken, 13 divided by 2 is 6.5. I believe that is correct. All right, good deal. Now, what we're going to go ahead and do is we're going to take a look at both of these numbers, okay? And we're going to see, do they fit those domain restrictions? So looking at this one, this first one, x minus 6, is 16, okay? Does he fit between negative infinity and negative 2? And the truth is, no, he doesn't, right? He's a much bigger number than that. And so this one is not one of our answers, okay? This is not, 10 is not going to fit for that part. But now let's take a look at the next part. We have our, and I'll use blue, 6.5. Now, does 6.5 fit in between negative 2 and infinity? And the answer is yes, indeed it does, okay? So we found the x value that goes with y equals 10, okay? So this right here would be our x value, okay, that we were trying to find, okay? So let's go ahead and do the process again, okay, for the number 8. So it looks like here that I have my x minus 6 is equal to 5. And then, oh, negative 5, right? There we go, let me fix that. And then I have my 2x minus 3 is equal to negative 5. Now, when I go ahead and start solving for these, okay, remember, I want to make sure that my x value ends up fitting into that piecewise domain, okay? So I'm going to add 6 to the side, so I got x is equal to 1, okay? And then over here, add 3 to the other side, I got 2x is equal to negative 2, and then x should equal negative 1. Now, let's see here. Does this x equals negative 1, is that between, or x equals 1, is that between negative infinity and negative 2? And once again, okay, we find ourselves saying no, it's not, right? So this right here is not going to be one of our x values, okay? But let's take a look at negative 1, okay? is -1 going to be between -2 and positive infinity? And the truth is, yes, it will be, right? -1 is between -2 and positive infinity. So this is the answer we're looking for right here. Alrighty, so now we're taking a look at number 9 and 10. What you'll notice off to the left is a rough sketch of that piecewise function for -x and 4, okay? So what I'm going to do is I'm going to use this picture to kind of help describe what's happening when we write the answer, okay? So that way you can have a little bit of a visual aid as well. So as always, what we're going to go ahead and do is we have to go ahead and put 4 equal to both of the equations, okay? So I have a -x is equal to 4. And then I've got my 4 is equal to 4. Now looking at this right here, I'm going to go ahead and solve for x for the left-hand side. And so I have x is equal to -4. And then of course 4 equals 4, that's already been solved for us. And in fact, that is also a true statement, okay? So let's go ahead and consider the left-hand side now first with the domain, okay? Is this, okay, x equals -4, is that between -infinity and 0? And the answer is yes, it is indeed. So this is an x value that we're looking for. So this one's good to go. Now, is 4 equal 4? Is that a true statement? And yeah, it is. So that means, okay, that we have the ability to include the x values from 0 to 12, okay? Because remember, 0 to 12, that's talking about individual x's, okay? And to be more precise, it's talking about these guys, right? This right here is talking about 1, 2, 3, 4, 5, 6, 7, all the way to 12, okay? And then, of course, 0, 2, is all 4, okay? At each one of these points, or each one of these x values, I'm going to have a y equals 4. So we have a little bit more of an answer, okay? What we're now going to be able to put is that not only do we have -4, we could also, or union, have 0 to 12, okay? And that is going to be my answer, okay, for number 9. Now let's go ahead and take a look at number 10. Alrighty, let's take a look at number 10. So number 10, once again, we have our -x is equal to 0, okay? And we also have our 0 is equal to 4. And actually, I'll go ahead and flip it the other way. I'll go ahead and say 4 is equal to 0, okay? Now, of course, we'll solve for the left-hand side, and we have x is going to be equal to 0. And then what we notice is 4 is equal to 0. Well, that's not a true statement, okay? So we understand that for this 0 part, that is not going to be an answer. And if we go ahead and take a look at the domain, okay, and we see that the domain is -infinity to 0. Now, with that being said, that means that we cannot include this because we don't include 0 for that part of the function. So if the left-hand side is not a solution and the right-hand side is not a solution, then we have no solution for this one. Alrighty, guys, that's it for the notes today. Thank you guys for your time. I'll see you in class. Let me know if you have any questions. Alrighty, bye.